Click the bell icon to get latest videos from Ekeeda.
Hello friends, in the previous topic we have discussed about the factors that were responsible for the color of the transition metal ions, and now in this topic we are going to talk about the colors of the transition metal ions. So what are the different colors that could be exhibited by a particular atom, especially the 3D transition series? This is what I'm going to talk about in this topic. So friends, in this topic I'm going to talk about the color that could be imparted by the transition metal ions, especially about that is 3D transition series. So talking about the first one, that is, suppose if we are talking about that is Scandium 3+ ions. So it is been found that it is colorless in nature. So this is what I'm going to talk about, that is why it is colorless in nature. So now for that we have a particular example. Suppose friends, if I'm talking about Scandium, and Scandium has an atomic number of 21, so therefore we could write it here as argon 18, 4s2, 3d1. So in this case, suppose if I'm talking about that is Scandium 3+ ion, so that means that is this 2 electrons along with this 1 electron, it will get removed, and that's the reason that suppose if I'm talking about Scandium 3+ ion, then the only thing that is what it has been left out is Ar 4s0 3d0. So as we can observe, that is the d orbital, it is completely empty over here, and there is no unpaired electron. And in the previous topic we have discussed about that is what are the factors that are responsible for giving a color to a transition metal compound. So in this case, since there is no unpaired electrons, and that's the reason that is what we have discussed in our earlier topic also, that is because of the unpaired electrons or because of the partly filled, that is d orbital, there will be d transition or the splitting of the d orbital. But in this case, since there is no electron in the d orbital, obviously there will be no splitting or there will be no dd transition, and that's the reason that this compound will not absorb any kind of that is wavelength, and that's the reason it will not give or it will not impart a particular color. So that's the reason Scandium 3+ ions will not exhibit any color, and that's the reason it is colorless. So this was one of the reasons, and now let me talk about the next one. So talking about the next ion, that is Titanium 3+ ions, is basically purpley in color. So for example, let me give you the elaboration about this, that is why it gives a color, why not Scandium 3+. So we have understood the Scandium 3+ is not exhibiting a color because of the empty d orbital, but now let us understand that why that is Titanium 3+ ion, it gives color. So talking about titanium, that is titanium has an atomic number of 22. So for that we could write the electronic configuration as argon 18, 4s2, 3d2. So since the fourth shell, and it consists of basically s orbital, and this 3d is nothing but the penultimate shell, so that's the reason that the electron, it will be removed from the 4s2 and then it will come to that is 3d. So for that, suppose if I'm talking about that is Titanium 3+ ion, so in this case the electronic configuration of this one would be argon 4s0 3d1. So in this case, basically if we talk about the number of orbitals, we understand that is the d orbital, that is the d subshell, it consists of that is 5 that is orbitals, but in this case it has only 1 electron. So this is 1 electron as well as this is 1 unpaired electron, and that's the reason this will have a chance to get excited from the lower energy level to the upper energy level, and we have also discussed about that is dd transition, and that's the reason that this will be involved in the dd transition, and that's the reason that it has a particular capacity to impart color, and that's the reason that it will absorb, that is this electron, it will absorb the wavelength from the visible region as well as it will give a complementary color to the compound, and that's the reason that Titanium 3+ ions are purple in color. So based on this theory, we are going to talk about the other ions and what are the colors of those. This is what I'm going to talk about. So now let us understand that one also. So talking about the next one, that is Titanium 4+ ion. It is basically colorless because as we have discussed for the Titanium 3+ ion, it consisted of 1 unpaired electron, but in this case there will be no unpaired electron that is basically located in the d orbital, and that's the reason it is colorless. So talking about the next ions, the next ions are that is Vanadium 3+ ion. So Vanadium 3+ ion is green in color, or those compounds in which basically the central atom, that is the vanadium, has basically an oxidation state of 3+, it is green in color. So talking about the next one, that is Chromium 3+ ions, they are violet in color. Talking about the manganese 2 plus, so in that case it is light pink. So talking about the next one, that is manganese 3 plus ions compounds, so in that case it is violet in color. Fe2 plus ion, for example, that is FeSO4, or we could call about that is FeCl2, so therefore those compounds are basically pale green in color. So talking about the next one, Fe3 plus ions, and those are basically yellow in color. For example, ferric chloride, that is FeCl3, it is basically yellow in color. So talking about the next one, that is cobalt 2 plus. So cobalt 2 plus is pink in color. Ni2 plus, it is green in color. Cu2 plus, we commonly known as CuSO4, so that is also blue in color. Talking about Cu plus, it is colorless. The reason the Cu2 plus is blue in color, because of the electronic configuration. Also we can look that is, suppose if I'm talking about copper, which has an electronic configuration of, we could write it here as argon 4s1 3d10. And suppose in this case, suppose if I'm talking about that is Cu2 plus ion, so in that case one electron, it will be eliminated from the 4s orbital, and that's how basically we could get 4s0, and one electron will get eliminated from this d orbital, making to here as 3d9. So in that case, if you talk about the orbitals, so we'll get 1 2 3 4 5 orbitals in the d subshell, and it consists of 9 electrons, so therefore we could fill it in this way: 1 2 3 4 5 6 7 8 9. So in this case, this consists of one unpaired electron, and this one unpaired electron gives the blue color to the Cu2 plus ion. But the number of unpaired electrons doesn't give a particular color. It depends on the metal also. It depends on the metal, and it depends on the geometry, and based on that it gives a particular color. For example, in the previous one, that is, suppose if we have discussed about that is titanium. So in that case, the titanium 3 plus ion, it imparts purple color, even though it has only one unpaired electron. But even the copper has one unpaired electron over here. But why the copper doesn't give purple color? Because it depends on the geometry, and it depends on the hybridization that the central atom undergoes through. So based on that, this is what I'm going to talk about later on. But now let us understand what are the different colors that could be exhibited by the other ions. So talking about the next one, that is Cu plus ions are colorless because it doesn't consist of any unpaired electrons left in the d orbital. And talking about that is Zn2 plus ion, so in that case basically the 4s orbital, it will be empty, while the 3d orbital, it will be completely filled with the electrons. And that's the reason that since the d orbital is completely filled with electrons, and there are no partly filled d orbitals, and that's the reason that it will not take part in the d transition, and that's the reason it is colorless. So now let me discuss more about the geometry, how the geometry or how the hybridization plays a very vital role in giving a color to a particular compound. So friends, we understand that is whenever the copper salts are basically dissolved in water, it gives blue in color, for example CuSO4. So in that case, whenever the copper ions, that is Cu2 plus ions, whenever it is reacted with water molecules, that is, suppose if I'm talking about that is 6 moles of water molecule, suppose it reacts with, so in that case it will form a complex, and the complex is what I'm going to mention about here, that is Cu H2O 6 times, and the overall charge of the complex is Cu2 plus. So we are going to talk about the nomenclature of this complex later on, but now let us understand that is what will be the color of this complex. So the name of this complex, it could be called as hexaquocopper 2 ion, and in that case we should understand that is the color that is being exhibited by this copper complex is blue in color. The reason behind that is of the geometry. If we understand that is there are 6 H2 molecules that are been surrounding this central atom, that is the copper, and that's the reason that the geometry that it would give, it is nothing but octahedral geometry. And based on this geometry, the color is basically blue in color. And the same example, suppose if I'm talking about that is, suppose if copper, that is this complex, suppose if it is dissolved in HCl. So in that case, the complex that it would be formed, it would be that is CuCl4 2 minus. So in this case, this copper complex will have yellow color. And the reason behind that is because here we can find that is the copper undergoes through a geometry which is nothing but octahedral, but in this case it has been found to be tetrahedral. So based on different geometries that are being exhibited by the same element, there are different colors. So that's the reason that it doesn't depend on the particular atom, but it also depends on the geometry of the complex, and it also depends on the hybridization of the central metal atom. So therefore this were all the reasons and all the different ions which impart different colors. So therefore that's it. Thank you friends for watching this video. I hope you have understood this video very clearly, and I hope I will see you next time. Till then, don't forget to subscribe Ekeeda channel. Thank you so much.